morning, dear Shem stars. How are you all, students? I hope you all are well at your home. Students, today we are going to start with the new topic, that is chapter number 8, permutations and combinations. Before starting with the topic of permutations and combinations, a very important thing, that is factorial notations, need to be understood. So let us understand what is factorial notation. If n is a positive integer and n factorial denoted by n factorial, that is n exclamatory sign, is the product of all the positive integers less than or equal to n, and it is defined by n factorial is given by n into with n minus 1, n minus 2 and so on up to 3 to 1. Remember that 0 factorial is 1. So that means factorial of 0 is always 1. For example, we need to find the 5 factorial. So 5 factorial will be given by 5 into 4 into 3 into 2 into 1. So that comes out to be 120 on calculation. Next is the 7 factorial. Similarly, 7 factorial will reduces to 7 into 6 into 5 into 4 into 3 into 2 into 1. On calculating, this will come out as 5040. Similarly, if we are given with 8 factorial over 6 factorial, that can be reduced as 8 into 7 into 6 factorial, and in the denominator we are writing it as 6 only. So 6 will cancelled with the 6 factorial of numerator. So the resultant will be 8 into 7, that is 56. Similarly, we can see other examples for the same. I hope the concept of factorial is clear to you all. Next, we are starting with the definition of permutations. So what are permutation? Permutation is the ordered arrangement of m things taken out of the list of n things. So that is denoted by npm and is given by n factorial over n minus m factorial. Suppose we are having 5 children in a class, out of which one is to be chosen as a monitor. So how many ways we can do that? That will be given by 5p1, that is 5 factorial whole divided by 5 minus 1 factorial. Next, you know how to calculate the factorial. So similarly, we can calculate the values for 7p2, that is 7 things are given to us and 2 are to be chosen at a time. Similarly, 10p8, that means 10 things are given to us, out of which are to be chosen at a time. So number of combinations or the arrangements that we can calculate. Now let us understand the concept with the help of some examples. So our question number 1 of exercise 7.1 is, how many 3-digit number can be formed from the digits 1, 2, 3, 4 and 5? Assuring that first part is repetition of digits is allowed and second part is repetition of digits is not allowed. So that means one digit can be used once only. Now for the first case, the number of digits given to us are total 5, and how many digit number we have to form? That is 3. So that means for filling up the first place, we have all the 5 digits available. Because repetition is available, so we can use again 5 digits for the second place and for the third place also. So that means the total number of combinations that can be made will be 5 into 5 into 5, that is 125. So writing 3-digit number out of these 5 digits are 125. Next, for the second case, when the repetition of digits is not allowed. For the first place, we have all the 5 digits, that is any of the 5 digit can come, so 5 ways are there. Next, for the second place, since one digit has already came at the first place, so only 4 will be left. Similarly, for the third place, only 3 will be left because repetition is not allowed. So hence the total ways that will come out for the 3-digit number will be 5 into 4 into 3, that is 60. That's all for today, students. Do revise what we have done in the class, and if you have any query, please feel free to ask on the Google Classroom. Take care. and have a great day ahead.